Today I'm going to be teaching and explaining what black body radiation is and the two theories that go along with it and how they look and are represented on a graph and what the two differences between the classical and modern theories are and what the evidence for the quantum theory is. So first things first, I want to define what black body radiation is. And black body radiation is when an object is heated up, and as it begins to heat up, it will start to emit radiation at all frequencies and wavelengths of the visible color spectrum. Now, this is really important because we're actually able to see the graphical relationship between frequency and intensity of that black body radiation and how it will be represented in the correlation between those two. So first things first, we're actually going to explain the classical theory and how it was the initial idea of what black body radiation did and what everybody thought that it would lead to. So we're going to look at the Rayleigh-Jeans theory. So these are two physicists, and their theory spoke about how the relationship between intensity and frequency was pretty much exponential. It continually increased, and the energy that it produced would also increase with no, limit point. So speaking about this actually developed into another theory that called the ultraviolet catastrophe. So this was the idea that from the original Rayleigh-Jeans theory that as a black body reach thermal equilibrium, it will emit the radiation at all frequencies and actually will exponentially increase in intensity to a point where it's producing harmful radiation. It's gotten to a point where it has not slowed down or decreased in its energy output because the frequency and intensity will just continue to increase. Now, this idea was something that actually caused quite an uproar and a bit of fear, because if this was truly what was happening in the classical theory of black body radiation, then anything that gets heated up that's a black body could end up being something that's potentially dangerous. So what happened in the year 1900 was a man by the name of Max Planck created what we call the modern theory, which was kind of his take or his opposition to the classical theory of black body radiation. And this is what the comparison of that idea is. So he provided a theory that not only defined the energy of the particles of a black body that are getting released, but he also was able to quantize those numbers into specific integers. And as he explained that, he was able to create a better equation and comparison of how intensity and frequency are related to each other. Now, this was something that was significantly more understood or accepted because as he made this mathematical explanation, he was able to show it once again in a graph and compare it against the Rayleigh-Jeans law. Now, what was so important about this is that as they made this comparison, he actually made his own constant that helped actually quantize the energy that would actually be produced. And it showed that, as we see and we look at this graph to our right on the slide, is that as the frequency increases and intensity increases, it will increase in energy and to a certain degree. But once it reaches a certain point of intensity and frequency, it would actually decrease in its intensity as it increases in frequency, showing that instead of the previously believed theory of Rayleigh-Jeans law, where it'll eventually increase to a certain level where the ultraviolet catastrophe will occur, it will actually begin to decrease in its intensity, showing that not only will black body radiation not get to a certain point to where it's dangerous, but it'll actually has a limited point of where it can reach at its certain intensity. Another thing that is quite interesting is that if we look at the graph, if we look at the base of frequency and intensity, the two laws actually agree with each other, showing that as frequency is at a lower point and intensity is much lower, the two equations would actually give us similar readings, and that's something that is quite interesting. But as we see, they begin to split off, and we can see the differences and why the quantum theory is much more agreeable, much more plausible, and it shows off how mathematically it would explain the uh, eventual behavior of blackbody radiation. And that is what made the quantum theory so popular, the accepted version, because we can see the relationship between what those particles will do and how they actually react. And that is blackbody radiation.